Polynomials, polynomial and synthetic division, long division and synthetic division. Using long division to divide a polynomial by another polynomial, synthetic division, and using the remainder and factor theorem. Divide this by this and then factor the rest of it. So long division is very similar to, well, long division. So the first thing we do when we do long division is we have our division bar. And we put what we're dividing by inside. 6x cubed minus 19x squared plus 16x minus 4. And we need to make sure that we have all the powers. So here we had the biggest one was 3, so we need 2, we need 1, and we need 0. 3, 2, 1, 0. We have it. And what we're dividing it by is x minus 2. Now the first question we did, and when we did this here, is, well, if each step in this process is to eliminate the first one out, x cubed. So what times x will give us 6x cubed? 6x squared. And I'm going to put it over the top of x squared. I'm going to line the variables up. 6x squared. So we'll multiply squared times x minus 2. Well, that would give us 6x cubed like we wanted, yes? 6x squared times negative 2 is negative 12x squared. Put it underneath. And then because 6x cubed minus 6x cubed is 0. So negative and negative make it positive. Negative 19 plus 12 is negative 7x squared, and we bring down the next term. All right, now we're going to repeat the process. What times x gives me negative 7x squared? And it kind of gives us a cheat, a little bit of a hint at the top. Because if you notice, I started with x squared, so the next one is x, and then we'll have a number. So it kind of helps us. So if we multiply through this by negative 7, so negative 7 times x minus 2 would be negative 7x plus 14, yes? We put it underneath. And then we subtract, and the first two are going to cancel out, yes? And then we would have a positive 2x, and we bring down the so 2 times x minus 2 would give us 4x, 2x, thank you. I don't know, got ahead of myself, 2x minus 4. Minus and minus, will these cancel? Those cancel, so we get 0. Now, whenever we get 0, it means it divides evenly. It divides evenly, there's no remainder. So when we divide this here, we get 6x squared plus 7, or 6x squared minus 7x plus 2. So 6x squared minus 7x plus 2 times x minus 2 gives us this here. Now we're going to find use the result, factor the polynomial completely. So we want to factor this. 2 sets of parentheses. And then we have x minus 2. Since the constant term is positive, the signs are the same and they match the sign of the middle term. So they would be 3x. And 1 and 2. Now we do have different multiples of 6 because we have 1 and 6 and 2 and 3. So we just picked 2 and 3, just because. Because what we do at the end is we check. 2x times negative 2 is negative 4x. 1 times negative 3 is negative 3x. And that gives us negative 7x, yes? So these right here, this is it factored completely. This is it factored completely. Questions on this here? And that's it. Now, if we wanted to solve it, we would set them equal to 0 and solve. As we look at this here, so we would do our division like we did. We get this here. So by factoring it, you have this here. And that's factored completely. Now in example 2, x minus 2 is a factor of the polynomial because the remainder is 0. So if the remainder, whenever we do long division, is 0, it is a factor. If it's something other than 0, it is not a factor. For instance, so let's do this one here. Long division. Divided by x squared plus 3x plus 5. So our first question is, what times x gives me x squared? X. So we'd have x squared plus x. I'm not writing that out because hopefully x times x is x squared. X times 1 is x. We can kind of see that, yes? And we would subtract. X squared minus x squared is 0. 3x minus x is 2x plus 5. So what times x is 2x? 2. So we'd get 2x plus 2. We end up with a remainder of 3. Now what we do is we come up here and say plus 3 over x plus 1. Because we put the remainder over whatever we're dividing it by. Since we're dividing it by x plus 1, we put it over x plus 1. We get the remainder of 3. So we set it up as the quotient plus the remainder over the dividend. Divisor. Dividend is what we divide. What is being divided by. And that's it. Questions on long division? Do y'all remember long division? We good with it? Yes? Now, the division algorithm of f of x and d of x are polynomial functions such that d of x is different than 0. We can't divide by 0, or we can't divide by 0 or divide anything by 0 because it doesn't tell us anything. Because whenever we divide something, or something is, we do 0 divided by something, or here, 0 times something, it's just 0. We just get the remainder. It's just, this is pretty much how we write it, where we have what we've divided by plus the remainder. D of x is equal to this f of x. There exists a unique polynomial q of x and r of x such that this is true, divisor, quotient, remainder. So pretty much we can write it. When dividing, dividend and divisor are decreasing in power. So whenever we divide, the power of what's being divided will increase by 1 each time. Because we're decreasing, we're making it smaller. We're taking one factor out. Insert placeholders for coefficients for missing power. So if it's not there, we have to rewrite it there with a 0. So, okay. So we're going to do one here. Here we go. Okay, this is the one I wanted. So what we're going to divide is this here. Now, hopefully you noticed that there are some variables that are missing, yes? Because we have 4, 2, 0. So if I write it in here, I have x to the fourth plus what? X to the third minus 8x squared plus 16. So I have to fill in those gaps. Even though they're not written here, I need them here. And we'll see here after the first one. And it's going to be, I'll tell you, it's x to the third. Because x to the third times x will give us x to the fourth. So it'll give us x to the fourth minus 2x cubed. Well, these will cancel. Now, if I didn't put that plus 0x cubed, it'd be kind of weird because we're subtracting something that now we have 0. We have something there we can subtract from. If I didn't write it, there's a tendency you would end up trying to subtract it from 8x squared. But we put that there as kind of a placeholder to let us remind us that there's not something there, so we're subtracting from 0. Well, minus and a minus give us plus, so we have 2x cubed minus 8x squared. X times what is 2x? Well, plus 2x squared, which will give us 2x cubed minus 6x, not 6x. Yes. 4x squared. Minus, well, those cancel, and this gives us negative 4x squared plus 0x. Minus 4x. Which will give us negative 4x squared plus 8x. That's just a step ahead, because 4 times 2 would give us 8. And it's positive because a negative and a negative make a positive. Those two cancel out, and I have minus 8x plus 16. Now, you're probably wondering, why in the heck did I pick 8x? Or, why in the heck did I even pick? Well, I picked 8, because 8 times 8, negative 8 times 1 is negative 8. It gets the first one to match up. And negative 8 times negative 2 is plus 16, yes? So this is our answer. Now, I also knew it because I knew this was divisible. I knew it was one of the factors. I actually set it up so that it was a factor. Is that okay? Now, what we're looking at next is synthetic, and synthetic division is normally the one that most people like, to do. It is way faster. Now, how we set it up is our cubbyhole, line. What we're dividing by, or it goes up here, and we just take the number, but we flip it. Or really, another way we say this is that we solve for it. We set it equal to 0 and solve. I subtract 3, so x equals negative 3. So here we're using the zeros. We're using the zeros of the function to solve. So the zeros of the function, the numbers that would make the function equal to 0, or we'd hope would be 0, we plug in here. Now across the top is going to be the coefficients. 1, 0, negative 10, negative 2, 4. We don't have an x cubed. We don't have an x cubed, so we have to be careful. Okay? Our next step is we drop the first number. Negative 3 times negative 1 is, or negative 3 times 1. Add. 0 plus negative 3. Negative 3 times negative 3. Almost. Negative and negative. Negative 10 plus 9. So this here does not divide evenly because the last number is not 0. But that's fine. For this one here, that's fine. Now, I box the last number, whatever it is, 0, 1, 7/9. I box it. This is for myself, to remind myself this is the remainder. The last number we get in synthetic division is the remainder. Now I go back through. This is the constant term. This is our x squared and x cubed. So we go like this here. Now, as we noticed and kind of mentioned earlier, we started with a degree 4. Now we have a degree 3. We go down 1. Plus 1 over x plus 3 is this here. And that be it, folks. That'd be it. That's all we have to do for here. That's how we would do the synthetic division. Now, if we knew more than one of the terms, I would do it again. I would just keep doing it. So we have it set up here. We go through, we find this remainder of 1. So we have this here. And that's it. So most of this is a review for what we've done. We've done this before. Do you all need to see another example of synthetic or long division? Factor theorem. The remainder theorem is if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. The remainder, what is left over? So if we plug a number in, like on the last one, we plugged -3 into the function. We got 1, yes? What it's saying is if I plug -3 into the function, into the each x value, I would get 1. It'd be equal to 1. So it's saying the remainder is the same, if when we divide, is the same thing as if we plugged it in. So that's a little crazy. So let's look back at this here. -3 to the 4th minus 10 times -3 squared minus 2 times -3 plus 4. Well, -3 to the 4th, 81. Okay. 3 squared. 3 times 3 is 9, yes? 9 and 9? 81. Because we have it 4 times. So the way I'm cheating to get this is, well, 3 times 3 is 9. Well, I can have 2 of those. 3 times 3 is 9. 4, 81. Now, we could have done it 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Either way works. Minus 10 times 9, because 3 squared, plus 6, -2 times -3 is 6. 10 times 9, well, -10 times 9 is 90. 6 plus 4 is? What was our remainder? It's the same. So that also means on the other side, going the other way around, because the remainder theorem stated if whatever the remainder is equal to the function with that number plugged in. Yes? Let's flip it. If I plug a number into the function, whatever it equals would be what the remainder is. Yes? So if, instead of doing long division, if I plug -3 into this here, I get 1, yes? That means when I do the synthetic division or long division, my remainder will be, either one works. Because the remainder theorem tells you that if we do this, like example 5, so if we use the remainder theorem here, and we plugged it in, we would get a value. Or if we use synthetic division, so we'd have 3, 8, 5, -7. Drop the 3. 3 times, we get -6. And then we add it to get 2. -2 times 2 is -4. Add those two together, we get 1. 1 times negative 2 is negative 2, which gives us negative 9. So if we plug negative 9 into this here, we would get, or not negative 9, if we plug negative 2 into the function, we would get negative 9. It tells us the same thing. So you obtain the following, which we got. So f of negative 2 is equal to negative 9. This means that negative 2 comma negative 9 is a point on the graph. You can check by substituting this in, but it's not a 0. It does not make the function 0. It doesn't cross. This isn't a point where it crosses the x-axis. Polynomial function f of x has a factor x minus k if and only if the remainder is 0. So let's combine the two that we just did. So the remainder theorem stated whatever the remainder is what would have been that value if we plugged it into the function, yes? This here tells me if the function equals 0 for that value, then it is a factor, yes? Which means it's a solution. Which means if I plugged it into the function and got 0, it means when I divide it by it, use synthetic division, I will get a remainder of 0. Which for us at this point isn't a big deal. It's not a big deal at this point where we stand. Since y'all have had Algebra 2 already, you kind of may, if you remember at this point in the chapter what we were covering, you have an idea of what's to come. But at this point, that doesn't make a big difference because plugging in a number and finding this value or using the synthetic division, there's not one that's going to be really faster than the other at this point. At this point. So we can do this here. Show that these two are factors. So this here would be x is equal to 2, and this is x is equal to negative 3. Which one do we want to do first? So positive 2. We have 2, 7, negative 4, negative 27, negative. Drop the 2. 2 times 2 is? 7 plus 4 is? 2 times 11. Negative 4 plus 22 is? 3 times 18 is 36. Negative 27 plus 6 is? 9. 2 times 9 is? And we get 0. And I can do this here. I could just continue to move on and do it this one or the original one. It doesn't matter. Because if negative 3 is a factor of this, it's also a factor of this one. Drop the 2. Negative 3 times 2 is? 11 plus negative 6, or 11 minus 6 is? Negative 3 times 5 is? 3. We show that they are both factors. Yes? So I'm going to show you this here just so you can kind of see that this does work. Negative 3, negative 6, 1, negative 3, negative 7, 21, negative 6, 18. That worked. The other one was 2, 4, 5, 10, 3, 6. It doesn't matter the order, because if it's a factor of 1, it'll be a factor of all of them. I'm just trying one out of the blue. Negative 3 times 2 is? So it doesn't work. Yep. I have a feeling this doesn't have any other factors. It's b squared minus 4 times ac 8 plus 6, 24. Okay, that's 1. 1. Okay. Okay. Erase all this here. Let's try negative 1. Negative 2 is? So there's ways to find it, but it didn't ask for that. I just went above and beyond. Some we have to do, some we don't. Here it just said show that it works. Since it became 0, it's a factor. Since it became 0, it's a factor. Now, this here, essentially what we ended up finding, will factor all the way down. But that's not too big a deal. But that's it.